So how do you decide which operating system to install? Well, you need to ask yourself a couple of questions. Has the decision already been made? The operating systems in use by an organization have a lot to do with the applications and systems that they need to run. Are you working with an organization or service that requires the use of a specific operating system? If so, you're done. That was easy. If a decision hasn't been made on what OS to use, or if you're looking for an operating system for personal use, then you need to ask yourself what software will need to be run on this device. In lots of cases, the software will be designed to run on a specific operating system. It's also possible that the software is cross-platform, meaning it can run on more than one operating system. Another question to ask is what hardware will be used. Modern operating systems do a pretty good job of supporting common hardware. You should keep in mind that some manufacturers allow their operating system to be only installed on their hardware. Still a little confused about which operating system is best for you or your organization? Check out the supplemental reading right after this video to learn more. There's one more thing I should call out. Remember that we have different CPU architectures, 32-bit and 64-bit. Our operating systems will also be optimized for this architecture, so make sure that the CPU and OS are compatible. If you have a 64-bit CPU, you should also install the 64-bit version of the operating system you choose. Okay, now that you've chosen an operating system that you want to use, let's work on getting it installed on our hardware. Many computers come with an operating system pre-installed. If you boot the computer in this condition, the operating system will continue from whatever point the vendor left it at. You'll need to do a couple of things to finish the installation, like choosing a computer name or host name, or configuring the network for the device. There's more, but we won't worry about that now. When we walk through an installation of an operating system, you'll be able to see this. If you're going to be installing an operating system from scratch, you can use different installation media. Some operating system manufacturers sell their operating system in disk form or USB form. Some let you do reinstalls directly over the internet. As an IT support specialist, you'll install an operating system many times, so using one single disk won't be time efficient or scalable. Scalability is an important concept that we'll cover later. If you want to scale or accommodate multiple computers, the added support is something you need to keep in mind. For now, you're only working with one computer, so let's focus on that. Let's just use a USB drive to install your operating system. Some OS manufacturers have their own special USB drives with the installation image, like Windows. For Linux, we can load up an OS onto any USB drive. Before we start installing our operating system, we need to be familiar with the concept of virtual machines, or VMs. A virtual machine is just a copy of a real machine. Why would you want that? We've been working with physical machines so far, but there are cases in IT support where we need access to a machine that isn't physically in front of us. Let's say I have a Windows machine, and I want to learn another operating system like Linux. I don't want to buy another computer or have two separate operating systems on my disk. Instead, I can use an application like VirtualBox to install Linux and have it completely isolated from my machine. Virtual machines use physical resources like memory, CPU, and storage, but they offer the added benefit of running multiple operating systems at once. They're also easier to maintain and provision. Virtual machines have become a staple in many IT departments, since they allow IT support specialists to create new virtual computers on demand. They can also reclaim the resources they use when they're no longer needed. If you wanted to use software that's only available on one specific OS, it's easier to create a new virtual machine, use the software, and then delete the virtual machines once you're done. Throughout this program, you'll actually be using VMs to perform hands-on exercises. You'll be working on our Quick Labs platform, where you'll be presented tasks to complete from within a lab setting. We list out the specific tasks you'll need to complete, and once you complete the tasks, you'll get the credit for the lab. Okay, now that we know what a virtual machine is, you can see how they can be extremely useful. We'll revisit VMs in the future and see their other many uses. We're covering a lot of ground fast. Since we're going to start installing operating systems soon, feel free to review these lessons to make sure you fully understand the fundamentals before moving on. The first operating system we're going to install is Windows 10 OS. This is the latest iteration of the Windows family operating system. If you buy the software in stores, it comes in a nifty USB drive. I have Windows loaded on a USB drive, and I'm going to go ahead and insert the drive, then boot it in a minute. But first, Let's make sure we have our BIOS UEFI boot order set to boot from the USB drive. Depending on what the manufacturer of your computer uses, you'll either hit F12 or some other key to access the BIOS settings. Looks good. Let's just let it run and we'll see it booting from the USB drive. Take note that your installation process might be slightly different depending on the version of Windows. Okay, I'm just going to click Next here. It's just asking for my language preference, my time and keyboard. Then I'm going to click the Install Now button. It's asking for a product key. I'm just going to go ahead and skip this. I'll do that later. And it's just asking me to agree to a software license term. So I'm just going to accept. Click Next. All right. Now it's asking which type of installation I want to do. I'm just going to click on Custom because I just want to install Windows. I select the drive I want to install it on. Okay, it looks like the computer restarted. Now it's just configuring updates. Once it's done updating, it's going to restart one more time. And now we're launched into the screen here that's asking us to enter in the product key. We're just going to go ahead and skip to this for now. We'll do this later. So I'm going to click Do This Later. And now it's asking if what kind of settings we want to use. We're just going to click Use Express Settings for now. Just want to start using our machine as quickly as possible. Okay, it's asking us to create an account for this PC. The first field is the username. A username is a unique identifier for a user account. I'm just going to go ahead and use my first name as my username. Next, I'll enter a password. Once that's done, we'll go ahead and finish our setup. It's starting to set up everything for us. Perfect. Now, here we are inside the Windows 10 operating system. Let's check it out. This is our user space. We have our desktop environment here where we can navigate our files, folders, and applications. The main screen here is called a desktop. In the bottom right corner here, we have a taskbar. This gives us quick options and shows us information like network connectivity, the date, system notifications, sound, etc. In the bottom left-hand corner here, we can access the applications, files, folders, and settings. You can also shut down, restart, and power off your computer from here. Let's move on to our system settings. In the main menu, go ahead and navigate to the settings. From here, you can change any of your system settings like display resolution, user accounts, network, devices, etc. Now, we're going to create a file in our operating system with our GUI. Let's create a file here on our desktop. All you need to do is right-click, and you'll see some options available. Then select New, then Text Document. Bam! Now we have a text file on our desktop. We just need to give it a name. How about My Super Cool File? And that's it! You just created a file in Windows. That wasn't so bad, was it? Now that we've seen how Windows is installed, let's go ahead and install the Linux operating system. Remember how I said that Linux has many different versions of their operating system called distributions? There are countless articles that highlights the pros and cons of the hundreds of distributions out there. We'll go with the most popular consumer distribution, Ubuntu. I've already loaded Ubuntu on a plain USB drive. Pro tip: since Ubuntu is open source, you can download the free operating system install image directly from their website and install it using whatever media you like. I've included a link to it in the next supplemental reading. I should also call out that you can't just copy the install file to a USB drive and expect it to work. It has to be copied in a way that makes the USB device bootable from our BIOS. To load the image onto your USB device and make it bootable, you can use a tool like etcher.io. You can also check out the link to the tool in the reading right after this video. Okay, I'm gonna go power on. And remember, we're gonna make sure that we want to boot from the USB device. Alright, now that it's loaded, you'll see an option if you want to try using the operating system first, or just install the operating system. We're going to do a fresh install of the operating system. The Ubuntu logo will pop up, and then we're going to have to go through a couple of loading screens while the system is installing. Alright, we're just going to go ahead and skip through all of these, and just pick the defaults for now. Alright, now it asks us for our name, a computer name or host name, then a username. The host name is used to identify the computer when it needs to talk to other computers. On our personal computer, it's common to just use our own names for our computer's name. But in an IT organization, we want to choose a good host name that follows a certain standardization. We'll go over that in a later lesson, but for now, let's just use an industry standard for host name like username-location. So I'm going to go ahead and enter in my name, Cindy. Then for the host name field, I'm going to type Cindy-NYC. Then for the password, we're just going to enter a password here. Then we're going to confirm. All right, then we're going to hit next. And then it'll ask us to restart once it's done. Awesome, now that's restarted, let's go ahead and log in. Great, now we're in the Ubuntu desktop environment. Here you can see where applications are laid out. On the left-hand side here, we have a dock that we can add shortcuts to. This layout may change since Ubuntu is changing their desktop environment in the near future. To learn more about this, you can check out the next supplemental reading. On the top right-hand bar here, you'll see quick settings for your computer, like network connectivity, Bluetooth connectivity, sound, and volume. There's also the time, a menu to power off, restart, sleep, and log out of your machine. Let's click on this menu and select System Settings. From here, you can change your system settings like your screensaver, resolution, hardware settings, and more. Let's go back to our desktop and select this icon here for files. This opens up a window so we can view our files. You can see the different files and folders here. If I click on Computer, I'm taken to the main directory of my system. We're going to get to this in depth in a later course, so for now, I'm just going to head back to my desktop. Now, let's do the exact same thing we did with our Windows machine and create a file. This time, let's just use commands in the shell. Because we're in a GUI, we don't have a program called bash that we run our commands in. Instead, we open up the search utility here and search for an application called Terminal. When you open up the terminal, you'll see your username, an @ symbol, the host name, colon, tilde, and then /desktop as your command prompt. This is used to show who's running the command. This will be more important in another course as you switch users. The last portion of the prompt shows you where you are in the computer. We'll learn more about this in a later lesson too, but you can see that we're currently in our desktop. You can verify that we're using the bash shell with a simple command, echo $shell. The echo command just prints out text options to the display. In this case, the argument $shell is the current shell, /bin/bash or bash. You could even do echo hello, and it would display hello, which isn't as useful. Okay, let's create a file in our shell. I'm going to use the touch command. Touch my super cool file. And here, you can see it made a file on our desktop. There are many different commands you can use to make a file, but the touch command is one of the simpler ones. Right now, it might be hard to understand why you have to memorize Linux shell commands when it's easier to use a Windows GUI. If you'll be working with any Linux machines, it's essential that you know these commands. Learning commands is also a stepping stone to process automation, which we'll cover in another course. Don't worry, by the end of this program, you should be super comfortable in the shell. Maybe you'll even run commands faster than you can in the GUI.
Now let's talk about mobile operating systems. So far, we've talked about two broad categories of mobile devices. Some mobile devices are general-purpose computing devices like tablets or smartphones. Other mobile devices, like fitness monitors, e-readers, and smartwatches, are designed to do a smaller set of tasks. General-purpose mobile devices generally use a mobile operating system that's derived from other operating systems. For example, Android is derived from Linux, and iOS shares a lot of core components with macOS. So how are mobile operating systems different from the OSs that they're based on? Mobile devices run on batteries that have to be recharged or replaced on a regular basis, and you want the device to last as long as possible between charges. So mobile operating systems are optimized to use as little power as possible, for example, by removing OS features and applications that the mobile device doesn't need. We also use motion, touch, and voice to interact with mobile devices in very different ways from desktop or server computers. This requires adding device drivers and support to the mobile operating system. More specialized mobile devices like fitness trackers, e-readers, and GPS devices often use custom OSs that are optimized for what the device is designed to do. These devices are even more slimmed down to run on very minimal hardware with very minimal battery power. They might also be built using specialized chips and peripherals, which more general-purpose operating systems don't know how to run. We've linked to some examples of these specialized mobile operating systems in the supplemental reading. There's a bunch more to learn about working with mobile operating systems, and we'll dive into that in another course.
We called out earlier that Chrome OS is an operating system based on Linux. Now, let's dive into how it's different from other Linux-based distributions. Unlike other operating systems, Chrome OS has one main purpose: to be a secure and simple way for the user to interact with the web. Not so long ago, the idea of having an operating system dedicated to running a web browser would have seemed weird, like it was underusing the computer. But today, you can do so much just through your web browser. You can communicate through email, create and share documents, edit photos, and even connect remotely to another computer. And the list continues to grow. The development of new web applications increases the number of things users can do, all within the web browser. This means that for a lot of people, most of their daily computer use happens inside the browser. So having an operating system built around a web browser makes a lot of sense. That said, Chrome OS is more than just a web browsing operating system. It can also run Android and Linux applications inside containers. The user interface in Chrome OS is customized so you can only see the Chrome interface. Process management, memory, and input and output are still happening behind the scenes. But you don't need to deal with any of that. You only need to deal with the browser. Chrome OS machines come pre-installed with the operating system, so there's nothing for us to install. When you log into a Chrome OS machine, you're also signing into the Chrome browser. Let's do that now. I've logged into my Chrome OS machine, It's pulling up my Chrome settings and extensions from the configuration stored in external servers provided by the Chrome infrastructure. This means that Chrome OS machines are interchangeable because most data is stored in the cloud, not locally. We'll learn more about the cloud in future lessons, but for now, think of the cloud as being somewhere else. Two other characteristics of Chrome OS are that it's extremely simple to use and very hard for users to meddle with. Since users don't have administrator rights on their Chrome OS machines, they won't be able to alter the system configuration. Also, Chrome OS has an automatic update mechanism that includes a failsafe in case anything goes wrong. This means that the user doesn't need to worry about problems or hacks in the system because it's designed to stay up and running. Finally, Chrome OS has strong security, which we'll learn about in an upcoming course. For now, you just need to know that Chrome OS allows users to browse the web without worrying about malware and to share machines while keeping their data private. It also ensures that data won't be compromised if the machine is stolen. In short, there's no need to worry about harmful software that might be out there because Chrome OS defends against these threats. As an IT support specialist, you may find that some of the users in your organization will choose Chrome OS for their daily work. Since it's so easy to use and rarely breaks, we won't cover daily support in further detail. The last operating system we'll go over is Apple's macOS. We won't go into too many details about how to use this OS. Instead, we'll focus on the ins and outs of the Windows and Linux OSs. But if you know one operating system, you'll be able to navigate any operating system. Fortunately, all Apple computers come with macOS pre-installed, so we'll just go through the important parts of the operating system. Okay, here's the desktop environment for our Mac. At the bottom here, you'll see a dock with shortcuts to your applications. In the top right, you've got the system information like the time and date, network connectivity, battery life if you have a laptop, and some other quick settings. In the top left here, you can see the Apple icon. This bar will change menu options depending on what application is open. But if you click on the Apple icon, you'll see more options. You can tell your computer to sleep, restart, and power off from here. The most important thing we want to look at is at the System Preferences menu item. This launches our system settings. From here, we can change any of our computer settings, like setting the orientation of our mouse scroll, adding and removing users, setting up printers, changing our screensavers, adding Bluetooth devices, and more. I'm going to click on the desktop now. You'll notice our top left setting changed from our System Preferences to Finder. Finder is the file manager for all Macs. If you open a new Finder window, you can navigate the files and folders on your Mac. If you right-click on a file, or if you're using a Mac laptop, you can use a two-finger click on a file to view more information and perform lots of different tasks. The Mac, which is a completely different operating system than Windows or Linux, operates in a very similar way with similar menu options. Wow, you've really come a long way. You've been introduced to the major operating systems used today, gotten to play around with the system, and even perform some common tasks. Nice work! It's important in any IT role to know the ins and outs of operating systems because you'll be interacting with them every single day. We have a separate course that teaches you all the essentials you need to navigate the Windows and Linux OSs. But for now, pat yourself on the back. You just took the first step towards understanding OSs. Installing, managing, and navigating operating systems are all tasks that you'll have to do daily as an IT support specialist. You may even find yourself doing this for hundreds, if not thousands of machines in your fleet one day. Before we send you to the next module, we have 2 assessments for you, which will test you on creating files with both Windows and Linux. You can always go back and review the videos again if you need a refresher. Otherwise, I will sign off for now, and we'll meet again in Course 3, Operating Systems and You Becoming a Power User.
Congratulations on finishing this lesson from the Google IT Support Certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.